Welcome back. Today we're going to be going over implicit differentiation. So implicit differentiation is a technique for finding the derivative of a relationship between two variables. And it's often used when it's difficult or impossible to isolate one variable to take the derivative with respect to the other variable. So now let's look at an example to see how we actually do implicit differentiation. So the idea is y and x are both variables, and in this situation, y cannot be easily isolated, so we couldn't easily put this into the form y equals everything else with x on the other side. So we use implicit differentiation, and when we take the implicit derivative, or when we use implicit differentiation to find the derivative of this function, whenever we derive a term with the variable y, we're going to multiply that by dy over dx, because we're taking the derivative of y with respect to the variable x. So the derivative of 2y, or y squared, is 2y, and we're going to multiply it by dy dx. And then we're going to add that to the derivative of x squared, which is 2x. And then the derivative of negative 3y is just negative 3, but we have to multiply that by dy over dx because it's the derivative of y with respect to the variable x. And then the derivative of x is just 1, and the derivative of 5 is 0 because it's a constant. So now what we need to do from here is isolate dy dx, because that's what we're trying to find. What does dy dx equal? So what we need to do from here is move everything that doesn't have a dy dx over to this side. So we want to isolate all the terms with the dy dx on one side. So we end up with 2y dy dx minus 3 dy dx equals, move this over, so negative 2x, move this over, minus 1, and now we factor out a dy dx. So to factor out the dy dx, we just rewrite this left side as dy dx times 2y minus 3, because if we were to distribute this dy over dx, we'd have 2y dy over dx minus 3 dy over dx, and that still is equal to negative 2x minus 1. And if we're trying to find what dy dx equals, we have to isolate it. So let's divide both sides by 2y minus 3. So here, these will cancel and become 1. So our final answer is dy dx equals negative 2x minus 1 over 2y minus 3. So another thing you might be asked to do with implicit differentiation is to find the second derivative, which will be written like this, over dx squared. So to find the second derivative, we do the same thing we did initially. So we're just finding the derivative of this, of dy over dx. But at the end, wherever we have a dy over dx, what we're going to want to do is plug in this value, this dy over dx, for that dy over dx in the newly differentiated equation. So I'll show you how to do that here. So now let's use dy dx and to find its second derivative. So we have to use the product rule here. So what we're going to do is take the derivative of the top, which is negative 2, multiply it by the bottom, and then subtract the top as it is, and then multiply that by the derivative of the bottom, which is just 2. But it's not just 2, because when we take the derivative of 2y, we have to multiply it by dy over dx. So it's 2 times dy over dx. And then we're dividing that all by the bottom squared. So 2y minus 3 squared. And now what we want to do is just plug in dy dx for dy dx. So our final answer for the second derivative is negative 2 times 2y minus 3 minus negative 2x minus 1 times 2 times plug in dy over dx, so negative 2x minus 1 over 2y minus 3, all divided by 2y minus 3 squared.